Good afternoon, dear students. The topic of today's lecture can be divided conditionally into three sections. The subject of general medical electronics. Here, we will consider such concepts as electronics, medical electronics, modern trends. The next section, ways to ensure safety when working with electrical equipment. Here, of course, the key word is security. Also consider the effect of electric current on the human body, protection against electric shock. And the third section, is the reliability of medical equipment. Here we consider a quantitative assessment of the reliability of medical equipment. The concept of electronics is quite widespread at the present time. Electronics is based primarily on the achievements of physics, as it is a technical science. As a result of achievements in the field of electromagnetic phenomena research, such branches of technology as electrical and radio engineering have been developed, and gradually many sections of radio engineering began to be called electronics. The term electronics itself is rather conditional. This is a field of science and technology in which the work and application of electrovacuum, ion, and semiconductor devices are considered, or it is the transmission, reception, processing, and storage of information using electric charges. In the broadest sense of the word, electronics can be divided into some groups by area, for example, application, or by class of devices used, and thus, in general, electronics is an applied branch of knowledge. All electronics are divided into three areas. Vacuum electronics. It covers the creation and application of electrovacuum devices. Cathode ray tubes, for example. Solid-state electronics covers the creation and application of semiconductor devices and integrated circuits based on them. Quantum electronics is a specific branch of electronics related to lasers. One of the common uses of electronic devices is related to the diagnosis and treatment of diseases. Podium concept of medical electronics. This is the electronics section, where the features of the use of electronic systems for solving biological problems, as well as the device of appropriate medical equipment, are considered. In modern medicine, electronics have replaced medical equipment that was not previously electronic. For example, the measurement of blood pressure, pulse, temperature measurement. Blood analysis identifies the following main groups of electronic devices and devices that are used for biomedical purposes. The first is a device for receiving, removing, transmitting, and registering biomedical information. This is information about the processes that occur in the human body, tissues, organs of the organ system. Information about the state of the environment, IDS sanitary and hygienic purpose. This also includes most of the diagnostic equipment. Many of them are characterized by the presence of an electrical signal amplifier in which the measured physical quantity is converted, for example, temperatures, and other indicators as well. This can also include electromedical equipment for laboratory research. The second is a device that provides a dosed effect on the body by various physical factors for the purpose of treatment, with a pacemaker for electrosurgery for therapeutic purposes. In other words, most devices of this class are based on an electric oscillator. In other words, electrical vibrations are transformed into electrical physical factors that are used for treatment and cybernetic electronic devices. These are computers for processing the storage of analyses to biological information, devices for controlling the processes of vital activity. In general, the use of electronic medical devices increases the efficiency of diagnosis and treatment, and increases the productivity of medical personnel. To obtain information about the parameters of a biomedical system, it is necessary to have a complete set of devices. It can be a measuring instrument, display devices, a recording device, but we will focus in detail on the shooting devices. An information retrieval device is a device that is directly in contact with the system itself. And these include electrodes and sensors. Electrodes are special-shaped conductors connecting a measuring circuit with a biological system. When diagnosing, they can be used not only to remove an electrical signal, but also to bring an external electromagnetic influence to the patient. They should be fixed, removed, be durable, not irritate the biological tissue. Many biomedical characteristics, such as pressure, temperature, cannot be directly removed with electrodes, since they are not reflected by a biological signal. And then sensors are used. Sensors are a device that converts a measured value into a signal that is convenient for transmission and further processing. Currently, in medicine, mainly sensors are considered that convert a measured non-electrical quantity or a non-electrical characteristic, such as, for example, the temperature of the pressure pulse during measurement, converts it into an electrical signal. It is convenient to register the information provided by an electrical signal, transmit it at a distance, and also process the result. According to the nature of the converted quantities, the sensors are divided into mechanical, piezo, sound microphone, temperature thermocouple, optical photocells. Sensors in which the energy of the output signal is converted by means of a sensitive element, for example, a photo and piezoelectric element, into voltage or current, are called generator or energy sensors. These include piezoelectric, thermoelectric, induction, and photoelectric sensors. Parametric, or also called passive sensors, are sensors in which the energy of the input signal is used only to measure the parameters of the sensor signal itself. These include resistance sensors, inductance sensors, inductive sensors, or capacitive sensors. Electronic medical equipment has displaced other types of equipment from the diagnostic and treatment process. At the heart of all modern electronic medical devices is a microcomputer unit that controls all modes of operation. Also look, modern trends include a significant reduction in the size of the creation of wearable electronics. That is, here we can classify it by size. It happens to be stationary electronics, that is, when the patient moves to a stationary fixed equipment. Then, there is also portable electronics, that is, this equipment is transferred by a doctor or technician to a patient. And wearable electronics. It is possible for patients to wear it for a long time, with minimal discomfort, equipment. And also the widespread use of communication technologies for the exchange of information. Our next section is called Safety when working with electronic medical equipment. One of the most important issues related to the use of electronic medical equipment is its safety for both patients and medical personnel. As I said at the beginning of the lecture, the most important keyword here is security, and for both patients and medical staff. In comparison with a healthy person, the patient sometimes finds himself in particularly electrohazardous conditions for a number of reasons. Well, these are the reasons you see the weakening of the body, the lack of consciousness, right, or the presence of electrodes on the body, that is, the presence of electrodes on the patient's body, which is intentionally exposed to current. It is directly connected to a DC circuit, either low-frequency or high-frequency current. And of course, medical personnel who work with medical electronic equipment are also at risk of electric shock. The effect of an electric current on the human body. The human body turns out to be sorry. Under the influence of an electric current cannot be considered only as a physical body. The human response to the actions of an electric current is very complex and diverse. And let's remember what an electric current is. An electric current is the directional movement of electrons under the action of a potential difference in a closed circuit. And having entered through the place of entry into the human body, it has an irritating effect along the entire path of the current, and not only in the places of its entry and exit. This is the peculiarity of the current action in comparison with other stimuli, mechanical, thermal, which cause only local irritation at the output. The biological action of the current is a complex process in terms of both the large number of organ tissues that can be involved in it and the depth of the primary mechanisms of changes in living structures at the cellular and molecular levels. The effects of electric current on the human body depend on a large number of different factors. The main ones are such as the magnitude of the voltage and current strength. Next, duration of the current action. That is, with a short-term exposure of 0.1 second, from 0.1 second to 0.5 seconds. A current of the order of 100 milliamps does not cause cardiac fibrillation. Excuse me. If you increase the duration of exposure to 1 second, then this token can lead to a fatal outcome. Also, the effect of electric current. One of the factors of the action of electric current is the path of the current passing through the human body of the circuit path. Then we can say, when a person touches only the leading parts of the path, there can only be different ones. In total, there are 18 options for closing paths only through a person. The main ones are, for example, the head, legs, arm, right arm, legs, left arm, legs. Especially dangerous are. Why they are particularly dangerous. For example, especially dangerous cases, lesions in which the current passes through the heart and lungs. Yes, that is, it is a hand from hand to hand, from hand to foot. The next thing is the rotatch and the purity of the electric current. Here we can talk about direct alternating current. Yes, types of mouth of electric current. Alternating current. Its characteristics are voltage, 220 volts, and the frequency of the current is 50 Hz. Individual properties of a person. Well, of course, this is the gender and age of a person's condition. These are also environmental conditions. Well, environmental conditions include humidity, air temperature, the presence of grounded metal structures and floors, conductive dust, have an additional impact on safety conditions. And also the resistance of the human body. The resistance of the human body between the two electrodes consists of the resistance of internal tissues and organs, and the resistance of the human skin. The resistance of the human body changes throughout the day, of course. The resistance of the body is influenced by the contact area, as well as the place of contact, since the skin resistance of the same person is not the same in different parts of the body. For example, the skin of the face, neck, armpits of the mucous membrane has the least resistance. The skin of the palm and soles has a resistance many times greater than the resistance of the skin of other parts of the body. The resistance of the internal parts of the body is equal to 1 kilo. For the path, the palm is the foot and weakly depends on the overall resistance of the person. The resistance of the skin during the passage of current from its surface to the internal tissues is 10 times greater than the internal resistance of the internal parts of the body. Therefore, for a constant and low-frequency current of 50–60 Hz, the resistance of the skin at point contact is the determining factor that limits the current. At high frequencies, the internal resistance of the body is a more significant factor. So therefore, in most situations, the current flowing through the body mainly depends on the state of the body at the point of contact. Dry skin has a high resistance, and wet skin will, of course, have a low resistance, since the ions in the moisture will ensure the passage of body currents. With dry skin, the resistance between the extreme points of the body, this is the palm of the foot, can be equal to 10 in the fifth ohm, and with wet skin, it can be 1% of this value. The total resistance of the body between sweaty hands takes equal to about 1,500 tons. The resistance of the skin significantly depends on internal and external causes. Sweating, humidity, yes, as we have already talked about it, or the presence of some kind of damage on the skin. And besides, in different parts of the body, the skin has different thickness and, therefore, different resistance. Therefore, taking into account the variability of the skin resistance, it is generally not taken into account in the calculations, taking the skin resistance equal to 0. The current flowing through the body is calculated according to the formula. The current strength is equal to the ratio of the voltage to the resistance of the internal parts of the body. I repeat that the resistance of the human body depends on the gender of the age of people and on their condition. At the same time, it is the magnitude of the active current that has an effect on the human patient's body. That is, an electric charge flowing through a biological object per unit of time. The magnitude of the current is the main parameter that determines the degree of damage to the human body. And the minimum value of the current, the irritating effect of which a person feels, is called the threshold of the perceptible current. That is, when a person feels tingling or tingling. So when you squeeze the electrodes with your hands, a feeling of current, well, that is, a tingling of the skin with a frequency of 50 Hz, appears at a current strength of about 1 ampere. Right. That is, for example, at the threshold of a tangible current, children have 0.5 milliamps, women have 0.7 milliamps, and men have 1 milliamp. This is the threshold value of the perceptible current. When the threshold value is exceeded, for example, from 3 to 5 milliamps, the irritating effect is already felt by the hand. And if we increase the current from, for example, from 8 to 10 milliamps, the muscles of the entire arm will involuntarily contract, and there will be a feeling of pain, since the flexor muscles of the arm are much more powerful extensor, and the arm bends in the joint, and a person with an increase in current from 15 to 12 to 15 milliamps, he cannot independently free himself from the conductor clamped in his hand, and therefore the minimum strength of this current is called the threshold of the non-releasing current, when a person cannot independently break away from the conductor. And here, too, there is a threshold of tangible current for children. This is 4 milliamps, for women 6 milliamps, for men 9 milliamps. The effect of electric current on a person is of a diverse nature. Passing through the human body, the electric current just causes a thermal effect, electrolytic, biological, and mechanical. Well, let's look at the thermal effect of the current. It manifests itself in burns of certain parts of the body, heating of blood vessels, nerves, muscles of the heart, brain, and other organs. The electrolytic effect of the current, it manifests itself in the decomposition of blood and other organic body fluids, and causes significant violations of their physicochemical composition. The biological effect manifests itself as irritation and excitation of living tissues of the body, which is accompanied by involuntary convulsive contraction of muscles, including the heart and lungs. As a result, various disorders may occur, and even complete cessation of the activity of the circulatory and respiratory organs. And mechanical action. Mechanical action leads to tissue rupture. This variety of actions of electric current can lead to two types of lesions. The first is electrical injuries. Electrical injuries are clearly expressed local damage to the body tissue caused by exposure to electric current. In most cases, electrical injuries are cured, but sometimes with severe burns, injuries can lead to the death of a person. And just electric injuries include electric burns, electrometallization of the skin, and electric signs of current. Let's look at what an electric burn is. An electric burn is a current burn caused by the passage of current through the human body as a result of contact with the current-carrying part. It is a consequence of the conversion of electrical energy into thermal energy. There are several degrees of burns. And the severity of the damage to the body is caused not by the degree of burn, but by the area of the burned surface of the body. Then electrometallization of the skin. Electrometallization of the skin is the introduction of the smallest particles into the skin, molten metal under the action of a current, and electric current signs. This is a skin lesion in the form of sharply defined rounded spots that occur at the points of entry and exit of the current from the body with tight contact, energized parts. Electric shock. The second type of electric shock is electric shocks. Electric shocks are the excitation of body tissues under the action of current, which is accompanied by a sharp, involuntary convulsive contraction of muscles under the action of current passing through a person. As a result, ruptures of tendons, skin, blood vessels, nerve tissues may also occur. Dislocation of joints, even bone fractures may occur. Well, as well as the defeat of internal organs, the defeat of the central nervous system. The most common cases of electric shock are associated with touching metal parts that are energized by the supply network. And the main requirement is to make isolation. Yes, to understand the key word isolation here. That is, the main requirement of insulation is to make it inaccessible to touch parts of the equipment that are under high voltage. To do this, first of all, isolate the parts of the devices that are energized from each other, as well as from the body of the equipment and from the patient's circuit. And what is a patient contour? These are electrical circuits that are in direct electrical contact with the patient's body. Isolation does not provide complete security. The first is that the resistance of devices and devices to alternating current is not infinite, and therefore there are leakage currents. This is a certain current, the leakage current of the device. It is connected with the fact that the insulation ages over time. Yes, it leads to damage by breakdown on the housing. That is, when the insulation is damaged due to high humidity, there is an electrical short circuit of the internal parts of the equipment between themselves and with the housing. Therefore, there are other methods used separately or in combination with each other. Look, this is, for example, the isolation of the current of the leading parts. This is protective grounding, protective zeroing, automatic protective shutdown, also the use of a small supply voltage of less than 42 volts and potential equalization. And now let's look at each of these methods separately and in more detail. Protective grounding. You can call it a working grounding. In other words, it is the connection of parts of the device with the ground necessary for its normal operation, the removal of static electricity charges, that is, intentional electrical connection with the earth, or its equivalent of metal, not only leading parts, that may be energized. And the purpose of protective grounding is to lower the voltage between the housing and the ground to a safe value. Protective zeroing. This is a deliberate electrical connection with a zero protective conductor of metal, not only leading parts that may be energized. In case of a breakdown, a short circuit occurs on the housing in which the fuse or the maximum current protection is triggered. That is, it turns off, the equipment is disconnected from the voltage source. Also, a protective shutdown device. A means of protection that provides automatic shutdown of the emergency installation when the leakage currents exceed the established norms. That is, there are permissible leakage currents. And it is used in all modern power grids, of course, in addition to protective grounding and grounding. The main classes of electromedical equipment. Depending on the degree of protection, the main classes of electromedical equipment are divided according to the degree of protection against electric shock generation, according to the method of additional protection, and according to the possible consequences of failure in the process. Briefly, according to the degree of protection against electric shock, the main protection of the product is with a normal degree of protection, which is equivalent to the protection of household appliances. Product B with an increased degree of protection. B is a product with an increased degree of protection of an isolated working part. CF is a product with the highest degree of protection of an isolated working part. For example, products with a working part that have electrical contact with the human heart. Next, according to the method of additional protection, they are divided into classes. The first class is a product that, in addition to the main insulation, provides for a joint connection of the supply voltage, grounding, and zeroing of metal parts available for touching. 1. These are products that differ from the product class. First of all, only because it has separate clips or terminals on metal parts that are accessible to touch, in order to attach them to an external grounding or grounding device. Class 2 products, in addition to the main insulation, also have additional, possibly together with the main additional insulation, that is, the presence of reinforced insulation. There are no devices for protective zeroing, but a power cord for a product of this class, or a cable is shown here. The third class is products that are designed to be powered with an products that are designed to be powered from an isolated current source with an alternating voltage of no more than 24 volts, or with a constant voltage of no more than 50 volts, and does not have external or internal circuits with a higher voltage. There are no devices for protective grounding. And also on the possible consequences of failure in the process of B, C, and G. We will consider this in a little more detail later. The next section is the reliability of medical equipment. Reliability is one of the most important indicators of modern technology, since such indicators as quality, efficiency, and safety depend on it, of course. Any equipment, especially medical equipment, it should function normally. And a device that does not meet the technical conditions becomes inoperable. The doctor uses medical equipment. Using medical equipment, he must have an idea about the probability of failure of the operated product, that is, about the probability of damage to the device or its parts, exceeding or lowering the permissible parameters. Therefore, what is reliability? This is the ability of the product not to fail to work in the data under specified operating conditions, and to maintain its operability for a specified time interval. The issue of equipment reliability is very relevant for medical devices. Why? Because the breakdown of medical equipment can lead not only to economic losses, but also to the death of the patient. The quantitative assessment of the reliability of medical equipment has a highly probabilistic character, since, in general, the ability of medical devices to fail safe operation depends on many reasons, all of which, of course, it is practically impossible to take into account. And the first one is the probability of trouble-free operation. This is the ratio of the number of T-devices operating during the time to the total number of devices being tested. This characteristic evaluates the possibility of maintaining the product operability in a given time interval. And is represented on the slide by the formula. The following is the failure rate indicated by the letter. This is the ratio of the number of failures over a certain period of time to the product of a given time interval by the total number of working elements. There is a minus sign here. Minus indicates that the number of working products decreases with time. Next, we have a graph of the lambda function at. It has a non-permanent appearance and somewhat resembles the time dependence of the parameter characterizing the mortality of the average person. There are three areas on the graph of the failure rate versus time. The first area is the run-in period, when hidden defects or hidden defective elements of the product appear, which arose during the manufacture of the device. And the dependence of the intensity of rejection on time during this period can be quite large, be great. The second area is the period of normal operation, where the failure rate remains constant, and normal operation of the equipment is planned for this period. That is, here the intensity, the dependence of the intensity of rejection on time, may not change for a considerable time. And the third area is the aging period. The failure rate increases due to the influence of aging of the material and wear of the elements, of course. Here, the dependence of the failure rate on time increases with the time of wear of materials, or equipment elements. It is interesting for doctors to know that the concept of reliability can be conditionally applied to the human body, considering the disease as a loss of performance, treatment as repair, and prevention as an event that contributes to improving reliability. But we know that an organism is a complex system, and a technical, so to speak in quotation marks approach, is only partially possible. Depending on the possible consequences of failure during operation, medical devices are divided into just 4 classes. The first class is Class A. Here are products whose failure poses an immediate danger to the life of the patient or staff. The probability of trouble-free operation of a product of this class should be at least 0.99. Products of this class include devices for monitoring the vital functions of the patient, artificial respiration devices, blood circulation. Reliability Class B is a product whose failure causes distortion of information about the state of the body or the environment, which does not lead to an immediate danger to the life of the patient or staff, or causes the need for immediate use of a product similar in function. The probability of failure-free operation of a product of this class must be at least 0.8. Such products include systems that monitor patients and devices for stimulating cardiac activity. A Class B product that reduces the effectiveness or delays the diagnostic and treatment process in non-critical situations, or increases the burden on medical personnel, or leads only to material damage. And this class here includes the probability of trouble-free operation of about 0.5. This class includes most of the diagnostic and physiotherapy equipment, tools, and so on. But a product of Class G that does not contain a failure of capable parts, electromedical equipment, does not belong to this class. Thank you for your attention.